Okay, students, now we are starting with one of the easiest and smallest chapter, smallest topic. Okay, I don't say it is important, it is scoring chapter. Okay, if you study around 2 to 3 reaction, that's enough for this entire chapter. Okay, so that means you should work less but score more. That is the scoring chapter. That is the difference between other chapters and this chapter. Okay, ethers very small chapter, but if you study in the examination point of view, you are going to score good marks. Okay, so first let us start with the ethers. That is none other than the topic ethers. Okay, so ethers contains, these are the functional groups but treated as a, being functional group, they are treated as a substitute in the naming. That is one of the bad thing happened with the ether. Okay, they are functional group, but while writing the name, what you will do, you will write it as a prefix. That means you are treating them as a substitute only. Okay, so like this, suppose CH2, CH2, OCH3. This is very simple example I'm taking. This type of questions will never come in near future. Okay, but for understanding the near future question, you should know this one. So here you have a chance to select the longest possible chain. Okay, so this is the longest possible chain, and this is the substitute. This is the substitute. Okay, so substitute must be written before and it should be written with the word root. Okay, so naming will be meth oxy, this methyl and oxy, and it is ethane. Is it understood, students? So methoxyethane, IUPAC name of the this ether is methoxyethane. And when you segregate, when you classify it into different forms, here on one side it is methyl and another side it is ethyl group. So this type of ethers are called as unsymmetrical ethers. What it is called as? Unsymmetrical ethers. Okay, unsymmetrical ethers. Okay, because both functional, both alkyl groups attached on the divalent oxygen are different. Okay, and here if both are same, like suppose this name I think understood, methoxyethane. Now if both side, if it is ethyl only, then it will come under this category, ethyl. Okay, now you have a independence that you can select any as a main chain, anything as a side chain. Now, so if I'm continuing with the same previous one, now it will be ethoxyethane. The name of this compound is going to be ethoxyethane. Okay, so this is about the naming and classification of ethers. Ethers are classified into how many types? 2 types, depending on the aliphatic ethers I'm talking about. In aliphatic ethers, if alkyl groups attached on the both side are same, then they are called symmetrical. If they are different, then they are called as unsymmetrical ethers, depending on the alkyl groups attached. Okay. Now coming to the naming of some typical examples. Okay, naming of the some typical examples. Let us take CH3, CH2, CH2, O, CH2, CH3. Okay, and here suppose this is the side chain. Okay, now when this question given in the examination, most of the students made a mistake. Okay, so what the mistake made, this is also they treated as a substitute, this is also they treated as a substitute, but such mistake should not be committed by you people. Okay, so here this is can be included in the main chain. The main chain must contain this also. Okay, so main chain must contain this part also. Is it understood, students? So numbering can be done from the either side, because it is third carbon from here also, third carbon from here also. Understood? So basically it is a pentane. On the pentane, second carbon atom contains ethyl and oxygen. So the name of this compound is going to be ethoxy. Name of this compound is going to be ethoxy and pentane. Okay, and where it is ethoxy is available? 3. So it will be 3-ethoxy pentane. Is it understood? And when you number, your numbering should be done as if it is a substitute only, not as a functional group. That means if multiple bond is there, then preference must be given to the multiple bond, not to the ethers, because ethers are substitutes. Nitro is a substitute. Even the functional group, in the naming wise, it is treated as a substitute only. Okay. First one, alkyl groups, halogens also treated as a substitute during the naming, even though they are functional groups. Ethers also treated as a substitute, even though they are functional groups, and nitro compounds also treated as a substitute, even though they are functional groups. These are the three functional groups. There is a some problem with these functional group. Okay, so these three functional groups you should remember, especially while naming. Okay, but nowadays what is the problem is that that type of naming questions are reduced. Nowadays that questions are not coming, even in the board point of view also very rare, and even competition point of view also very rare. So students started not studying the IUPAC name, but it is indirectly required for both. IUPAC naming is required for both board exams, NEET exams, and mains or any engineering exam, because in reaction their name will be mentioned. So until unless you don't know the structure, then it is very difficult to write a big mechanisms and find the product also. Okay, so naming is not lost its glory. It's still, it is glorious topic only, but it lost its glory in the direct question form. Okay, so if you want to answer some questions of the recent level, still naming is required, but direct naming questions are not being asked. Okay, so that's why I give an introduction in the starting only in the ethers. Okay, so aliphatic ethers already we have studied, and aromatic ethers means there will be two ethers which are most and most important with commercial name. Okay, when on the benzene ring, methoxy. So its IUPAC is not much important, but common name is most important. Anisole. What it is called as anisole. Methoxy benzene is commercially called as anisole. Okay. Now, if I replace it with ethyl group, then it is called as a phenatol. So these two are commercially important names. If ethoxybenzene is called phenatol and methoxybenzene is called as anisole. In aromatic side, for the examination point of view, these are more important, and rest all naming you can do from the various books available in the market. Okay, so it does not involve any explanation. So wherever which are important, they only we are going to cover it here. Okay, so that is about the ethers. And isomerism. Ethers are functional isomers of the alcohols, because they're both, suppose C2H6O. If I write, this is a basic example I'm taking. My intention is to make you understand easily. Okay, so this is a molecular formula. So molecular formula, sorry, compounds having same molecular formula but different structural arrangements are called as functional isomers, different functional groups. So if I arrange them like this, it is still having 2 carbon, 6 hydrogen and 1 oxygen. It is methoxymethane. Here it is a ether. But by using the same number of element, even I can form alcohol also. Okay, CH3, CH2, OH. Understood? So this is what functional isomerism. Ethers shows functional isomerism with alcohol due to similar molecular formula. Due to similar molecular formula. Okay. So naming we have completed, and isomerism part we have completed, but correspondingly ethers have less boiling point than the alcohol. This is a conceptual question based upon the ethers. Okay, ethers having same molecular formula, if it is in the form of the alcohol, boiling point is more, and in case of the ethers, the boiling point is less due to non-availability of hydrogen directly connected to oxygen. Okay, so like in previous example only I will tell you. So here CH3. Okay, so here CH3, CH2OH. So here you can find this hydrogen is directly connected to oxygen. Okay, so then it can form the hydrogen bonding. But there is no hydrogen bonding. There is no hydrogen directly connected to oxygen. So there cannot be hydrogen bonding. So due to weak intermolecular force of attraction, their boiling point is low, and here boiling point is more. Even though molecular formula is same, the ether will have higher boiling point. Ether will have higher boiling point than corresponding, sorry, alcohol will have higher boiling point than corresponding ether with the same molecular formula. Ether with the same molecular formula. The reason is in alcohols, they possess intermolecular hydrogen bonding due to presence of one hydrogen directly connected to oxygen. In ethers, there is no hydrogen directly connected to oxygen. Okay, some basic students may ask, sir, here three hydrogens are connected, but they are not directly connected. They are connected. Their actual structure will be like this. Their actual structure will be like this. Okay, so this is the formula. So here they are not directly connected with oxygen. We write CH3, but they are connected with carbon. Understood? So no hydrogen is directly connected to oxygen. No hydrogen bonding, less boiling point, more volatility. More volatility. Is it understood? It is a question of the chemical bonding also, question of ethers also. Okay. Now coming to basic nature. Basic nature will be more because alkyl groups that we are going to study in the chemical properties anyhow. Okay. Now we are going to start with the preparation. Start with the preparation. Okay. So if you are already prepared, if you are already studied about the alcohols, there is a case where ethers also formed. Okay. So dehydration. First method is dehydration. Okay. What is the first method? Dehydration. Okay. Dehydration, what you will do? Alcohols. Okay. So as I told you, in organic, everything you will study at least two times. How many times you will study? Two times. One will be in properties, another will be in preparation. The same reaction you must have studied in the properties of alcohols. Okay. Again, you are going to study it here, but in the preparation of ethers. Okay. So here again I am dividing this into the two parts. Okay. By concentrated. First part I am going to take dehydrating agent as a by concentrated sulfuric acid. Second one I am going to use by Al2O3. Okay, there are two dehydrating agent I am going to use. Okay, my purpose is to eliminate the water from alcohols only, but that purpose is fulfilled. That process is done by the two different reagent. By using concentrated sulfuric also, I can eliminate water. By using Al2O3 also, I can eliminate water. Okay. The importance of this reaction is it is a temperature dependent. Okay. So normally there are some questions, reagent difference will be there. There are some questions where reactant difference will be there. Selective oxidation, selective reduction. Okay, there reactant should be concentrated. And if same reactant but different reagents are used, different product will be there. Like that, here you have to concentrate on the, when this question comes, you should concentrate on what temperature he has given. So the examination point of view, what is important here? Temperature is important because this reaction is giving product as per the temperature value. Okay, so in NCRT, in this one there are only two reactions. Okay, in the NCRT wise there are only two reactions in this part, but I will teach you as an extra effort four methods. Okay, four temperatures, four product. What are those four product? What are those temperature? We will study. Okay, so first concentrated sulfuric acid. Now first segment is, we are in the segment of preparation of ethers. In that first part is dehydration of alcohol. In that first part is concentrated sulfuric acid as a dehydrating agent. Are you ready? Okay. Okay, students, now we are in the very first segment of the first part. Okay, we are preparing the ethers from alcohol and we are using concentrated sulfuric acid. What sulfuric acid? Concentrated sulfuric acid. The speciality of this reaction, Already I told you this reaction is temperature dependent. Okay, and there is still some contradiction over this temperature. Somebody says 180, somebody says 170. That is not an issue. Okay, so let the 170, 180 both are same only for the examination point of view. Okay, so one nearby one high temperature. In some books simply they mention high temperature. Okay, high temperature there will be elimination, dehydration, intramolecular. What it is? Intramolecular dehydration. Okay, that means it will not use any other thing for dehydration. From one molecule only, both H2O are removed. Okay, so H2O is removed from one molecule, then it is called as a intramolecular dehydration. At high temperature, it is preferable to undergo intramolecular dehydration. Okay, if the temperature is low, then bimolecular or bimolecular and intermolecular. Okay, bimolecular and intermolecular. Two molecules collectively loses one molecule of H2O. This mechanism is more important. That's why I will specially emphasize and I will tell you also. That is not a problem. But comparative study I am telling you. Okay. At very high temperature of 170 to 180, alkene is formed by loss of one water molecule from one alcohol. One alcohol, one water molecule loses, alkene is formed. Two alcohols, one water molecule gives ether. Okay, when temperature is further reduced, then this sulfuric acid also participates in the reaction with the alcohol. Till now it is not, it is acting as a dehydrating agent only. So here it also helps out in the, it contributes by providing something to the reaction. Okay, so here see, it is attached with OH and H will be removed from, this is not contributing at all. Here all contribution from one molecule of alcohol, here contribution from two molecule of alcohol, here contribution from sulfuric acid also. Okay. Now, here we cannot say it as a dehydration. Basically, when temperature further reduced, it will form an addition product. What it will form? Addition product. Okay, it will form a salt. So this is negative, this is positive. It combines with here. One of the hydrogen comes over here. So H plus coming, this will become as a cation. And OH is already there. Now it is written as a OH2 and left over with HSO4 minus. Okay. So these are the four conditions. But for NCERT basis, okay, these two are more important. Okay. So this already we have studied in the 11th class also, preparation of alkenes. So need not to worry very much about it. Now we are going to study in-depth study of the ethers from the bimolecular, intermolecular. Two molecules are depending and two molecules loses one water molecule. Okay, how it is possible and what are the steps involved? What are the conceptual questions based on this? We are going to see that. Okay, comparative study of alcohol dehydration by using concentrated sulfuric acid at various temperature. I think it is understood. Role is same. If I change with Al2O3 also, no problem. Purpose is same only. Okay, but temperature may change, so need not to worry much about the Al2O3 if you're perfect in concentrated sulfuric acid. Okay, now we are going to start with the dehydration, bimolecular, intermolecular dehydration of alcohol to give ether. Okay. Okay, now here we are with the mechanism. Okay, so it is a acid reagent. What we are using? Acid, sulfuric acid. As an acid, its basic nature, as an acid, its basic nature is to provide H positive. So this reaction will be initiated by H positive. Okay, H positive is a electron deficient because of the positive charge. So in this entire molecule of alcohol, electron rich portion, where is electron rich, it is does not have not a single electron. It is in a very bad condition, not a single electron. So it will search for the place where it is going to get electrons. So the electrons rich is oxygen. So it will go and form bond with it. Okay. So once here you can see 3 bonds are formed by the oxygen. So that means positive charge. Oxygen positive, that means nitrogen. Nitrogen can form 3 bonds. Understood? Why positive charge? This positive charge is given to it and lone pair accepted by it and form as a covalent bond. First part, is it understood? So this is the positive. Now the special condition. Okay, when temperature, when one more alcohol will act as a nucleophile and attacks at the positive. Because of this positive charge, it will attack at it. Okay, so why this is more better than this one? Because it is having one lone pair and positive charge. It is having 2 lone pair. So the attack of the next ethyl alcohol is only required. Attack of the next ethyl alcohol is only required. Such possibility will be there when temperature is low. Okay. So when temperature is low and alcohol is in excess. Okay. So that time what happens? This will go and attack. Low, this is donor, this is acceptor. Now a intermediate compound is formed by loss of H2O. Okay, one water molecule will be lost and their intermediate compound will be there. Still there is a positive charge on the oxygen. Okay, see here, I told you the reagent is sulfuric acid. So it provided the H plus in the starting, but it should be given back. So then what happens? This electron will be taken by it. Okay, electron will be taken by, given to oxygen. Okay, so once this electron is given back to this oxygen, hydrogen will be lost as a minus H plus. So it is gaining electron. Now it will become as a 0. Okay, charge will be 0. So this side ethyl, oxygen. So CH3 CH2 twice O. Is it understood, students? So this is the mechanism. Okay, I think now it is clearly understood. Main thing organic problem is why, how you will come to know this will come, because it is an acid. And how you will come to know it will go at this place only, because it is not having any electron rich area, it is going to participate. And why it is attacking on at this place only? Because it is electron rich and it is electron deficient portion, positive charge. Okay, so now the oxygen cannot accommodate so many bonds, that's why it will lose water molecule. Then again, as the reagent provided H positive, it should be given back. That's why this product. Okay, so this mechanism is Sn2 mechanism. Which mechanism? This mechanism already you must have studied in your 11th class reaction mechanism chapter also. Otherwise, haloalkane also you must have studied Sn2 mechanism. Okay, why I am telling you Sn2 mechanism here? It is because it will be easy, it will be required to understand the non-possibility. Okay, this type of reaction possible only if it is a primary alcohol. Okay, primary alcohol, because Sn2 rate determining step is depending on the steric hindrance. For Sn2 to occur, steric hindrance must be least. So if you take 2-degree alcohol, if you take 3-degree alcohol, this attack is not possible. Okay, so that means this type of ethers where involves alcohol which is a 2-degree or 3-degree, they will not give this type of ethers. Understood? So ethers which are primary, alcohols which are primary alcohol can participate in entire this reaction due to low steric hindrance and good yield of ether is found. Okay, is it understood? So this is about the mechanism of preparation of ethers by using concentrated sulfuric acid at a temperature of low temperature of what temperature? 140 degrees Celsius. Okay, what temperature for ethyl alcohol it is? 140. If I increase the temperature, already you must have studied OH from here, H plus here, then it will give you the elimination of water molecule in one single step only. Okay, in one single step only you are going to get alkene. Okay, one molecule loses one water molecule. Okay, so next coming to the Al2O3. As I told you just now, sulfuric acid and same role is played by the Al2O3 only. Okay, but only thing, temperature will be different. Temperature will be different if it is 250 degrees Celsius. If the temperature is, otherwise I will clearly write it. Okay, now I think it is clear to you. Al2O3 also dehydrating agent, but temperatures are different. There we used 140, 170 and 180. Okay, so whatever is happening at 170, 180 will happen here at 350. Okay, so you need to worry about low temperature and high temperature. That's all. Values are not much important. And at low temperature, it undergoes bimolecular elimination of water molecule from two molecules. Okay, so to give ether. Is it understood? The preparation of ethers from alcohols and by using concentrated sulfuric acid, 4 condition, by using Al2O3, 2 conditions, and in one condition in all of them is going to give you ether. Okay, now we are going to start with the very most important segment, preparation of ether from Williamson synthesis. Very important for the board point of view because it is a naming reaction. Very important for the competition point of view because it is conceptually and mechanism wise also very marks in fetching. Okay. Okay, most important segment of this class. In sulfuric acid part, only two temperatures important and Williamson synthesis entirely important. Okay, in this chapter I told you only 2 to 3 specific topics are there. If you go through them, this is the most important topic for the preparation side. Okay, so Williamson synthesis is used for preparation of both symmetrical and unsymmetrical ethers by using sodium alkoxide with alkyl iodide in presence of dry ether to form ether. Understood? So here sodium alkoxide, sodium, alkyl and oxygen react with the alkyl iodide. Iodide is preferred so that reaction can be bond breaking will be easy. Bond length will be more, so bond breaking will be easy. Okay, and to avoid any further reaction, with the water, this dry conditions are maintained. Okay, so if I provide water, then water is going to react with them and this product may not be possible. So to avoid unnecessary disturbance from the water, dry conditions, dry solvent, dry ether is used. Okay, so this is best suitable for unsymmetrical ethers. We got a choice. Okay, now the most important question comes, which of the following is the best possible pair to prepare this alcohol, this ether? Okay, so for selecting the reactant pair, that is most important is here. Let us take most important example, most asked question is about CH3. This is the most repeated question. Even NCRT also contain this. This is I wanted to prepare. Okay, so I can prepare in the two different set of reactants. Okay, first I can write sodium here, CH3, C, CH3, CH3ONA when treated with CH3 iodine. Okay, this is one mechanism. And another mechanism is CH3, CH3 and CH3 and O, here it will be iodine and CH3ONA. Okay, so when you see from the direction, what is there? Just sodium and iodine will be removed and this will form. Sodium and iodine will be removed, it will form. Okay, but it is not practically, that is not possible. Okay, even though it appeared to be visually very easy, sodium iodine this or sodium iodine this, what is there? Okay, but it is not like that. Okay, for a reaction, for a good yield, you should make sure that degree of haloalkane should be lowest one. Okay, its degree should be low because the attack of the nucleophile takes place through the Sn2 mechanism. Which mechanism? Sn2 mechanism. Okay, if degree is low, what is low? If degree is low, then only this nucleophilic attack on this will be easy. Otherwise, in this condition, this nucleophile cannot make backside attack. Already, you must be aware of it. Sn2 reaction, backside attack takes place. Okay, so this CH3O minus cannot attack from this direction because already bulky methyl groups are there. Understood? So thus this reaction is not possible. Okay, instead of giving this reaction, what it will do, it will undergo elimination. Okay, so here what will be the product if we wanted to prepare this, but what we will get, we will get like this CH2C, sorry, we are going to get this product CH3 C double bond CH2 single bond CH3. Okay, this is the product if we use this pair because of the elimination. Okay, we were thinking about the substitution, but the product will be eliminated product because bulky group, this iodine and this carbon hydrogen both will be eliminated in presence of this nucleophile and elimination will be carried out. Okay, so there should be very important thing you should make while selecting the reactant. You should make sure that degree of alkyl halide should be lowest and degree of alkoxide should be highest. Then only this type of product is possible. What should be the reason? Because nucleophilic attack will be easy when degree of alkyl halide is less due to less steric hindrance. Is it understood? Mechanism is very easy and already you have studied in your haloalkane chapter also. Okay. So, but for the betterment side, I will explain the mechanism also. Don't worry about that. Williamson synthesis is preparation of ether by using sodium alkoxide with alkyl iodide in presence of dry ether. That is the naming reaction. So if it comes in the examination, board exam, if you wanted to write, what you will write? Williamson synthesis is preparation of ether. Preparation of what? Ether by treating sodium alkoxide with alkyl iodide in presence of dry ether is called Williamson synthesis. And for competition point of view, it follows Sn2 mechanism. It follows Sn2 mechanism. So for selecting the alkyl and sodium alkoxide, the degree of the alkyl halide should be lower and degree of alkoxide should be higher. Okay, this is for aliphatic. Now there is a different rule for the aromatic. What is that rule? I will tell you. Okay. Okay, now let us say this product I wanted to prepare. Okay, what I told you its name, it is anisole. If I replace it with C2H5, it is called phenol. Okay, now again I got two choices. Okay, I will think that both condition it is going to form. What is that condition? First condition is ONA treated with CH3I. This also it should give another pair of reactant which can be iodine, okay, plus CH3ONA, okay. So for the sake, it both appear to be very same, okay, dry ether. So both of them appear to be very same. This is sodium phenoxide, methyl iodide, and here phenyl iodide and sodium methoxide. Okay, so both appear to be same, but out of them both is not suitable. Which is not suitable and why it is not suitable is only the main reason. Okay, so here the proper reactant is this one and improper reactant is this one. Okay, why? Because the partial double bond character. What is that? Partial double bond character. Also, you can guess the answer. Otherwise, you can tick the answer. Otherwise, aromatic substances does not undergo nucleophilic attack. Okay, so here this has to attack or not, but nucleophile cannot attack on the aromatic substance. Aromatic substances undergoes only electrophilic substitutions. So two reasons you can say partial double bond character. What is that partial double bond character? I will tell you. So this iodine is there. So this double bond will be there. Okay, it will participate in resonance. So now it appeared to be single bond, but after some time there will be double bond. So it is very difficult to break this iodine. Okay, so that is first thing. Otherwise, nucleophile cannot attack on an aromatic substance to undergo substitution. Aromatic always undergoes which substitution? Electrophilic substitution. Okay, but this mechanism is nucleophilic substitution. Okay, so but here see, here steric hindrance is minimum, and this is a nucleophile. Nucleophile can attack on alkyl group, but nucleophile cannot attack an aromatic group. That is the difference between both of them. Okay, Williamson synthesis, its advantages and precautions to be taken while selecting the pair of reactant for the same product. I think it is now clear. Okay, now we will start with the mechanism. Okay, simple. Those who have studied the Sn2 mechanism, same we are going to do it here. Now let us take, this is iodide. Okay, now first RO dash, this is the nucleophile. Okay, so there is a transition state. I think everybody remembered this Sn2 mechanism does not involve formation of carbocation. But what it makes a difference? If no carbocation, no methyl shift, no phenyl shift, no rearrangement, so direct product. Okay, so there will be transition state. Rather, what it will be there? Transition state. Okay, so here this this will keep on eliminating, this will keep on attaching. Okay, so there will be a transition state. Bond of the iodine and carbon reduces, and bond between oxygen and alkyl group will increase. Okay, this will be forming, and this is called as a transition state. After a certain time, this completely bond will be eliminated, iodine will be completely eliminated, and this formation will be there. Okay, is it understood? Ethers are formed. What is formed? Ether will be formed. This is the ether. Okay, any doubt about this? These are all regarding the Williamson synthesis. Most important things you will remember in the today's lecture: Williamson synthesis, how to select the reactant set. If it is a aliphatic, you should make sure that degree of alkyl halide should be less and degree of sodium alkoxide should be more. If it is aromatic, then try to keep that aromatic group with the aryl oxide. Okay, and haloalkane must be, alkyl group must be with the iodine. Okay, then next, what is the next one? Next, coming to the sulfuric acid method, there what you have to make sure? You have to make sure that the temperature, low temperature, high temperature. In low temperature, bimolecular elimination to give ether, and high temperature, single molecule elimination to give alkene. Okay, bye bye, see you.